Good evening, everyone. Welcome to the week 7 on problem solving session for industrial wastewater treatment. The course instructor for this subject is Professor Alok Sinha and Professor S.K. Gupta from IIT ISM Dhanbad. My name is Manetnam Prakash and I am from IIT Kanpur. So we meet every Tuesday from 6 p.m. to 8 p.m. on Google Meet, and the recording of this session is being uploaded on the YouTube channel, and the link has been also shared with you, so you can always go back and watch it if you have any kind of doubt in previous 6 session. So in week 7 we dealt with this topic, that is treatment of wastewater produced from distillery and dairy industry. So till now we were this we will be looking into different type of industry. So previously, we have looked into different methodology, how to treat organic matter, heavy metals. So different methodology was were there. Like either we can use some kind of coagulants, precipitant, or either we can use a oxidizing agent like OH radicals or hydroxyl radical. So now we will be using those methods to treat different kind of wastewater produced from different industries. So first is this distillery and dairy industry. Okay, so first there will be a small brief recap in very short. It will take hardly 5 to 10 minutes, and then again, as usual, we will be having this problem solving session. I have several questions, and I will be discussing it one by one. In during in between discussion, if you have any kind of doubt, you can always write in chat box, or you can unmute yourself and you can speak. The chat box is open, the mic is also open, so you have freedom to say anything and to write anything. Okay, so this thing is very. If you have gone through the lecture, we have seen that these industry produce alcoholic beverage like whiskey, beer, and rectified spirit. And in India, if we talk about this thing, then 13.80 billion liters are produced annually. Okay, then we have molasses, and the second is grain waste. Molasses is like a means like it's when how it's a black substance consisting produced from sugar cane only, or there are it can be produced from other thing only, other soil, but it contains around 50 to 60% of, not 50 to 60%, but around 30 to 40% of content of sugar. Okay, and it is fermented, and from here we produce sugar, or some alcohols are also made with some kind of fermenters and all. The main Miss Government is interested in, because we know that we are what do I call, like there is a ethanol blending targets, like for our what do you call, for our petrol, and many sectors are there which are like to increase the efficiency and all these things. And there are other reason also. One of the reason is efficiency. There is a province of ethanol blending. So you might have heard that our petrol come with some ethanol blending and all this thing. So government want to produce ethanol in higher amount. So there also this industry play a important role. Then different wastewater is, we will be looking at spent was, like this is the at the end, and this one is a major pollutant. Okay, now we will be looking into what is this uh, a spent was, then a spent leaching, then we have cooling water. Then what is the characteristic of this spent was? It is a highly acidic, that is pH is around 3.7 to 4.5. It contain high amount of chemical and biochemical biological chemical oxygen demand and BOD. Okay, and it is up to around 2 lakh. You can see this much amount of chemical oxygen demand is there. Means huge amount of organic matter is there. Okay, and mainly these industry use carbon source. Like we have seen molasses or grain. In both cases, there is a huge amount of carbon is there. So, and carbon is a source of organic matters. So that's why this huge amount of uh, COD is there. Hmm. Then contains sulfate. Then where is my one? Huh. Then we have high amount of contains sulfate chloride. These are some of the anions which is also present. Okay, na. Pollutant effect, a 30 kiloliter, it is KLD means kiloliter, 10 की power 3 liter per day. Okay, now this 30 liter kiloliter means 30,000 liter per day creates pollution equivalent to sewage from 5 lakh people. A spent waste volume is 50 times the ethanol produced. Okay, now so whatever the ethanol is being produced, 30 times, 15 times is the spent waste. Okay, now then we have alcohol production and treatment technology. Batch process is there. Then this is older and have means a huge amount of waste and lower efficiency there. Then a advanced, yeah, modern treatment method, production method was developed, that is biosteel process, and a lower amount of waste is produced, and it is more efficient also. Treatment method are two types, that is anaerobic digestion, that is most common in India. Then we have upflow anaerobic sludge blanket. Like here we are treating in the form of in absence of free oxygen. Then we have upflow, means there are series of a structure where wastewater is passed, and different treatment unit treat our wastewater. Then we have hybrid reactors. Okay, now higher efficiency, it consists of several things. Okay, now I don't exactly recall what is this hybrid, means what it's make, but you can see that it has efficiency of very high. Means generally the full name is high anaerobic hybrid reactors, AHR. Okay, now or HAR, the hybrid anaerobic reactor. Sometimes both terms are also used. Okay, now energy recovery, biogas generation, 30 KLD distillery produce this much of biogas. So we know that in aerobic digestion, at the end of the system, we have methane production. Okay, now so whatever the sludge or waste is being produced here in this industry, this can be treated by this method, and a methane gas can be produced that can be used for biogas. Okay, now methane yields this much meter cube. These data are directly from your PDF. Okay, now then we have another industry, brewery industry, that beer production. Okay, now so India has 489 breweries, largest United in Bangalore. We have largest production of this beer. Then for 1 liter of beer, 4 to 6 liter of water is consumed. Again, it has high chemical and biochemical oxygen demand. pH varies between 7 to 4 to 7 due to cleaning agent. High phosphorus and nitrogen content is there. Anaerobic treatment is there. Chemical neutralization is there. And biogas recovery from effluents is there. Finally, we have dairy industry, that is milk industry. But India is, we know that world largest milk producer, around 230 million tons of milk is produced annually. Processing wastewater, cooling, heating, and these are some of the method by which we are handling the wastewater. Then we have to cleaning wastewater equipment, cleaning spillage way, sanitary wastewater. Characteristics of dairy wastewater, it has again high chemical and oxygen demand, chemical oxygen demand and biochemical oxygen demand, and total suspended solid is also very high. That's why contain fats, protein. We know that our milk contains these things. Milk waste pH vary between 4 to 7. A huge range of pH is there. Then the treatment method are mechanical. We can treat first. We have mechanical screening flotation to remove this suspended solid and all these things. Then we have chemical miss. There might be something which can be precipitated. Then we have biological. Again, we know that a high amount of COD and BOD is there. Then we have to remove the a high amount of organic matter is there. Then we have to treat it biologically. Okay, now one example is from Sun Snadaj dairy plant is where these methods are being followed. Okay, so these were just four type of miss like four. These were mainly four topics which were discussed in week 7. Okay, now so we will be discussing question one by one. So as usual, if you have I request everyone to please participate, and most important that you will be able to easily able to answer this question if you have gone through the lecture. So this is the first question: how much sugar is present in sugar cane molasses used in distillery industry? This thing I have discussed. If you have gone, if you were listening to me, you can answer it. We have A option 70 to 80%, or 80 to 90%, or 50 to 70%, or 10 to 20%. Please, in chat box, write your answers. See, this cannot be answered 80 to 90%. Our pure sugar, which we generally eat, contain this much amount of sugar. Okay, now so this cannot be answer. I request everyone, please. D. Okay. Yes. Correct answer is D. The correct answer is D. That sugarcane molasses used in distillery industry contain. Typically contain 50 to 60% of fermentable sugar, mainly sucrose, glucose, and fructose. While molasses does not contain other organic compound, its sugar concentration is lower than 70 because some sugar are lost during the sugar extraction process. So see, molasses miss like this. There is a huge amount of molasses. If you like, how to explain it? Like molasses are being used at many, like several people used in compost also. But here, these were just example, but here I am talking about in production of this alcohol and all these things. So what will happen that add they will take molasses, they will add some fermenters, some yeast kind of thing, and what will happen that this alcohol, this will convert into some kind of alcohol. Okay, now so that's why you cannot procure molecules directly from anywhere. If you someone see with you molasses without any permission, then there can be a like uh, legal like you have to deal with law, and these molasses are not easily available. Okay, now. So, for example, in Kanpur there is one industry, there is one college, sugar college, that deals with this molasses, that produce molasses. Okay, now. So there was once for our lab there was one time that we needed molasses for one of the experiment. So we have to deal with means like we have to write a letter from our director from IIT Kanpur to the director of that college to procure some, maybe 1 kg. I think we procure only 2 kg of molasses, and we have to give in written that this is only for research purpose, not any other activity. Okay, now. So this is interesting thing about molasses. This is too high for molasses. It represents the sugar content of concentrated sugar syrup rather than molasses. This is sugar in refined sugar that we generally use. Okay, now this is too low. Even the lowest sugar molasses I have. Molasses is widely used in ethanol production because it's high sugar content, but not as pure sugar syrup or sugar cane. Okay, so this was question number one. This question number two. We told you that there are two method, batch process in okay now. So and there is biosteel process. Okay now. So I'm assuming that you have all gone through the video lectures. So which of the following option is the correct in fermentation of molasses in distilleries? We got one answer, that is B. Biosteel process require minimum time of fermentation. Yes, that is correct. The biosteel process is advanced fermentation method used in distillery that significantly reduce the fermentation time. It implies a special yeast strains and optimized fermentation conditioning, allowing for a faster conversion of molasses sugar into alcohol compared to the traditional batch or continuous process. This makes the biosteel process highly efficient, leading to the increased ethanol yield and productivity in the distillery. So generally, what is if you people also say that the batch one is the older or traditional method. This biosteel is the modern method. Here there is high efficiency. There is in batch process there is a problem of pH also. Then, but in this new modern method there is no such problem of pH. There if you have if you have gone through the lecture, then there is this table. Just let me show you the table. So you can see this is the batch process where like in a single batch something is passed, but here some advanced mechanism, and here you can see that comparison of batch. Here you can see that uh, in batch you can see there is requirement of pH adjustment, high consumption of steam is there, a huge amount of waste is also produced, alcohol yield is very less, pre-fermenters is required. But here in this method some other, as name suggests, by that's why there is no need of any pre-fermenters. You can directly add your molasses directly into this process, and it contains sufficient amount of yeast, or which I won't say yeast, fermenters, which helps to ferment the molasses. Okay, now. So you can see then these are some of the spent like these are some of the characteristic or spent mass which is produced from batch process and biostate process. Okay, now see the I miss. Okay. Then why other batch process? No, while fermentation allow for control condition, it does not necessarily produce better alcohol compared to the modern continuous or biosteel process, which are designed for efficiency and purity. Okay, now. What is the optimum pH used for fermentation of molasses in fermenter? Again, this thing, if you have gone through the lecture, you can say it. pH, optimum pH range. Remember, different pH range. In last example, we have seen the in last what do I call? Uh, in last example, in last session, we have seen about methanogenesis. Okay, na methane formation. There we have seen that the optimum pH range is between 6 to circumneutral between 6 to 8. Okay, na. Similarly, there is a definite pH range for fermenter. Can anyone say B? That is 6 to 8. No, 6 to 8. I don't know. A 5 to 6. No, the correct answer is I think D. The correct answer is D. The optimum pH for fermentation is between 3 to 2. The acidic pH range is preferred because see, there are many regions. See, again, that's why I ask everyone to go through the lecture. Okay, now here you can see the pH range. I have noted down the uh, where did it go? Okay, just I'm not getting here, but see, the pH range is between. This is for a spent wash. But remember, miss, I'm not going to go through the lectures, but uh, uh, pH range is 3.5 to 4.5 because this at lower pH, a lower pH inhibits the growth of unwanted bacteria, especially lactic acid and other contaminants that can compete with ACE. Enhance yeast formation. Yeast strains such as this can tolerate highly slightly acidic condition and perform well in this range, leading to the efficient fermentation. So generally, whatever the bacteria that is responsible, or yeast generally yeast is responsible for fermentation. So the pH range is basically in the acidic range, that is 3.5 to 4.5. Okay, now improve ethanol yield. Maintaining the pH in this range ensure optimum enzyme activity involved in sugar breakdown, boosting ethanol production. Okay, now so these are some of the region. These are some of the method by which these are some of the reason why this pH is between 3.5 to 4.5 is generally required for fermentation. Okay, now this is the correct answer will be 3.5 to 4.5. While yeast can survive in this range, it is more prone to bacterial. Those who have said 5 to 6, in this there will be bacterial contamination and the fermentation efficiency will decrease. Too high increase the risk of bacterial growth, leading to inefficient fermentation. Again, alkaline pH is not suitable for yeast fermentation will not occur. So in this pH range, those who have said C, no one has said C, but those who have said A and B, remember these are the reason why it cannot be. The correct answer will be D, that is 3.5 to 4.5. See, I am just saying this thing in very brief, but if you go through the video lecture, there you will see like Sir has explained in a better way why this pH range is there. A spent mass is generated from which of the following units? A, boiling column. Yeah, correct answer is A, boiling column. Spent was generated from boiling, also known as analyzer column in dictionary during the distillation process. Okay. See, this is just a waste. Okay, na. A special name has been given, like this is especially used for distillery, but it is highly acidic and all these things. So this boiling column, and it has very pungent smell. I have mis experience of this. So, miss, in my village, I remember that uh, people used to make this alcohol from this molasses, desi daru, which we call. So, what will happen that they have this setup, what do I call? Distillation setup. So, after a huge amount of water will produce as a waste. Okay, now so in distillation, what will happen that a droplet will be the pure alcohol will be consumed on the other part, and the this waste that is known as spent wash will be collected on the other side, and it will be really dark. It will be very miss like I don't know which kind of a smell, but it smell really bad, and it is really acidic in nature also. Okay, now so and its color is really dark and all this thing. In distillery, the fermented wash is heated in the boiling analyzer where ethanol is vaporized and separated. See, both things are separated. The leftover non-volatile residue which is rich in organic matter and is called a spent wash. Okay, na? So pure alcohol will go on the one side, which will be collected on other separate that will be used as alcohol, and the non leftover part which rich in organic and inorganic matter, and that is generally the waste which has to be treated before disposal. But the spent wash is highly polluting effect with high biochemical oxygen demand, BOD, and chemical oxygen demand, requiring proper treatment before disposal. Okay. These other options are incorrect because the column is mainly for purifying and increasing the ethanol concentration, not for generating a spent wash. This condensation column is used to condense ethanol vapor, not produce a spent wash. Exhaust column, there is no standard exhaust column in distillation. The correct answer is A. The spent liquor in biosteel process is recycled to achieve the following. Answer this question. D. To dilute the molasses to maintain the sugar content. Yes, the correct answer is D. To dilute the molasses to maintain the in biosteel process, the spent liquor, also called the recycled effluent, is used primarily to dilute the molasses before fermentation. This helps in maintaining the appropriate sugar concentration in fermentation, ensuring optimal yeast activity. Okay, so just this was to I hope this is correct. Reducing other option, there are other options also. Reducing fresh water consumption, making the process more sustainable, minimizing the wastewater generation, improving the overall efficiency of the distillery. So it's like recycling thing. There will be some part which will be sent back to the main unit where it will dilute our molasses. That will help for the in a proper fermentation. Okay, na. Why other options are incorrect? This alcohol is produced by yeast fermentation, not by adding a spent. So this is alcohol production is another thing. Okay. The to maintain the temperature control is managed by cooling system, not by recycling a spent liquor. To equalize the pH adjustment is done using the acid or alkali, not by adding. And also remember this in biosteel, there is some other mechanism for pH. That's why throughout the system, when we got our waste and all this thing, the pH is already maintained. There is no need of maintaining the pH again, as in the case of batch. So this don't get confused with this option. Okay, now thus the correct answer is to dilute the molasses to maintain the sugar content. This is the easiest question. A distillery of 30 KLD capacity operating in batch process will roughly generate following quantity of spent wash. 30 KLD is there. Okay, 30 KLD is there. What will be the answer? We have seen how many times in my if you have gone through the PDF also, there also they have seen how many times how much how many times will be the spent was, that is 50 times. Okay na, so 30 into 50, 15, it will be 450. So the correct answer is D. This is like this is approximately, and if you have gone through the lecture, you might recall it. You can see here it was in first, second. Spent was volume 50 times, 15 times the ethanol produced. Okay, na. So this much is used for. This is directly linked. Like if you link like the ethanol produced, so per ml this time, it's around like. Uh, per ml whatever is coming in the system 30 times will be getting converted into a spent was. Okay, so that's why the answer is 450. Anyone have any doubt? In batch process, the spent was generally typically the 50 times the distillery alcohol produce capacity. Okay, which of the following statement is correct in case of breweries? Now we have come to the beer production. Okay, now till now we were looking into alcohol production, now we are dealing with the beer production. Correct, they are asking for the correct option. What is the correct in case of breweries? B. We have got one answer. A steeping process is carried out for the removal of impurities and bleach out of the color. Yes, the correct answer is B. Steeping process is carried out for the removal of impurities and bleach out the color. Impurity steeping is the first stage of malting process where the barley grains are soaked in water for 24 to 48 hours. The purpose is to removal of the impurities such as dust, dirt, unwanted material, initiating germination by increasing moisture content in the barley, bleaching out the color by washing away the unwanted pigments and the surface impurities. So, yes, the correct answer is B, that is to removal of impurities and bleach out the color. C, who was saying C? Why C is not correct? Spent water is produced from brewery. The breweries mainly produce spent germs and wastewater, but the term spent water is not commonly used in brewing. Remember, the spent water is generally used for this distillery, other where there is a production of alcohol and all this thing. Okay, now I hope you have remember these are terms, some a specific industrial term. Okay, now a spent term is not generally used for brewing industry. Malt house, A option was malt house is more polluted than brewery. Brewery blend from has higher organic because we are here we are directly using grains. Okay, na. Uh, then we have D option, none of these. Okay, so the correct answer is B. Okay, na. So B is the correct answer. Left the meeting. Which of the following statement is correct in case of dairy? Now the eighth question is related to dairy industry. Dairy industry generates 2.5 liter of wastewater per liter of milk. Pasteurization is carried out for removal of inorganic impurities and color. Ultra heat treatment is carried out at temperature less than 750 degrees Celsius. 750 Celsius is there. Okay, na? Which of the statement is correct? Anyone? Which of the following statement is correct? A. Yes, the correct answer is A. That is, dairy industry generates 2.5 liter of wastewater. The dairy industry is high waste consuming industry and generates a significant amount of wastewater. On average, 1 liter of milk is produced. The dairy industry produces approximately 2.5 liter of wastewater. The wastewater come from cleaning operation, milk spillage, equipment washing, and bioproduct processing. It has high organic load due to presence of protein, fats, and lactose, requiring proper treatment before disposal. Okay. Why other options are incorrect? Pasteurization is carried out for removal of inorganic. Pasteurization is simply heating process. Okay, now it does not remove inorganic impurities. Is to kill harmful bacteria and not to remove inorganic impurities. Ultra heat treatment is carried out. Is carried out at temperature of 135 to 150 degrees Celsius, not at 70 degrees Celsius. Okay, now for fewer second, not below 75 degrees Celsius. Okay, now. So the correct answer is uh, A. Okay, I hope all of you are. This will be this is degree 75 degree zero will be above. Okay, now there is this printing mistake. Hmm. So coming to numerical question, I request everyone to solve it. It is really easy question. Okay, now so it's saying that methanol is generated in anaerobic. We know that methane is generated methane CH4. Okay, now so it's saying that having a BOD concentration of ethanol. Okay, now how much like this much BOD is coming and the flow rate is this much 400 into 10 400 into 10 ki power 3 liter. Okay, now liter this much of it's coming liter per day. So here you have to apply two things. You should know that per gram of BOD how much methane is produced. Does anyone remember how much methane is produced per what do we say per milligram? How much methane in meter cube per milligram per kg of BOD? How much methane is produced? Anyone? Does anyone remember in last semester in sorry last semester in last session I have discussed this thing 0.35 meter cube per kg. No one remember this thing. This is sad. So see, first we have to determine the total BOD. Okay, now the total BOD we know the flow is for. Uh, oh, there is a mistake. Oh, no, removal efficiency 75%. Okay. Uh, there is one mistake here. It will be 450. Okay, now in question there is mistake. It will be 450. Okay, not 400. Okay. So you can see 400 into kiloliter. I have changed into see liter per day. That's why multiply it by 100. Okay, into 5,000 milligram per liter. It is saying 5,000 milligram per liter. Now I have to convert milligram into kg. That's why multiply it by 10 to power 6. And efficiency is efficiency 0.75%. 75%. That's why multiplied it by 75%. I have multiplied it all these three, and we have got this much kg per day of BOD is being removed. Okay, now so this whatever this BOD has been removed, it will go to the anaerobic chamber. Okay, for anaerobic treatment. Okay, now and here be methanogenesis. There will be four method, that is acid hydrolysis, then acid formation, then acetone formation, and finally this thing methane formation. And we know that theoretical methane is itna this much meter cube kg per BOD. And how much BOD we have? 16875 kg per day of BOD is there. So methane formation will be 0.35 into hmm, so methane formation will be 5906.2 meter cube. Any doubt here? Any doubt? No. Just, actually, I have copied this from. Hmm. Question number 10. 500 meter cube day per day meter cube per day of brewery plant having COD concentration of itna is treated aerobically in treatment plant. The effluent COD concentration is found to be 50 milligram per liter. Determine how much oxygen will be required daily for the plant. Okay, na. So we are reducing this much concentration to this much. Then how much oxygen I have to apply? So again, the process is simple. First, we have to change the unit here. Here you can see the unit is given in meter cube per meter cube per day. Okay, na. And the concentration unit is given in milligram per liter. Okay, na. So first, what we have to do is that we have to convert either this meter cube into liter or this liter into meter cube. So be it will be easier to convert meter cube into liter, and that is by multiplying it by 10 to the power 3. Okay, so the in or we can say that the flow is 500 into 10 to the power 3 liter per day. Okay, and so how much BOD is coming? BOD is coming 450. And how much final BOD is how much? That is 50. Okay, now so this much is being removed. Okay, now milligram per liter. Again, if I have to convert into kg, then I have to multiply it by 10 to the power minus 10 to the power minus 6. Okay, now so this thing I have also written here also. You can see 500 meter cube, this much gram. I have converted milligram into liter. See how it will be converted, gram per gra, gram per milligram per liter. So if you convert into 10 to the power minus 3, it will be gram, and liter it will be 10 to the power minus 3 meter cube. So this milligram per liter is equivalent to gram per meter cube. Okay, now so that's why here you can see gram per meter cube is there, and this I have kept meter cube per day as it is. Okay, now so this meter cube will get cancelled out, and it will be 2000 kg 2000 gram per day. Okay, and the theoretical oxygen demand is 1 point okay, na this will be 1.42 gram per COD. Okay, na, not BOD. Okay, na, COD. Okay, na, so the oxygen demand will be 1.42 into 2000. Again there is one mistake. It is gram, not kg. Okay, na, gram. So I have multiplied this BOD with BOD will get cancelled out. This gram. Uh, Sorry, let me check once. It is gram. Oh, there is. It will be kg. So here it is already. Just let me do it myself. Okay, now. So I think there is some unit. Actually, I have copy pasted. So here, it will be 500 into 400. Okay, sorry, 400. So it will be 2000. It will be 20 uh, into 10 ki power 4. Okay, na. So it will be 200 kg. It will be 200 kg or 2000 kg. How much it will be? And it will be, it will be just 200 kg. It will be okay, na. It will be 200 kg. Okay, na. 200 kg it will be. Then we know that per again, I have to check this thing. Methane production is this much. Hmm. So this, see, remember 1.42 gram of O2 per COD. So there is one printing mistake here. Okay, now theoretical oxygen demand is 1.42 gram of O2. Gram of O2. Remember. So I will modify it here. So so uh, first it will be like um, uh, so it will be this much, or here in this case it will be 200 uh, 20,000 grams. Remember what we were calculating. We were where did it go? We were calculating 500 into 400 gram. Okay, na. So it will be triple zero. There will be two more zero. Okay, na. This much gram per kg. Okay, na. So here also I will make one correction. 200 two one two three gram. Okay, it will be this much. Okay. So now I have to find out the total oxygen. Okay, na. So total oxygen will be oxygen required. oxygen required will be 1.42 into 1 2 3 4 5 gram. Okay na, and that we can calculate. If we convert into kg, then it will be kg. This thing will be gone, this 30 will be gone, and it will be 1.42 into uh, 1.42 into 200, that is 284 kg O2. Okay, everyone got it? Did you get it? This will be final answer, 284 kg O2. So there was slight mistake, and here you can see it. Anyone have any doubt? Okay, I will be discussing this thing only, a numerical question only. So related to this thing only, related to this topic one only. I have another BOD and COD question. So we can everyone try to solve this thing. There is again one. So till now, any doubt? From here you will have a better idea. Okay now, so again this much 50 kiloliter, that is 50 into 10 ki power 3 liter per day, okay, of alcohol is produced. The BOD concentration is the raw spent is this much. This is our wastewater. Okay na, spent wash is our wastewater. Okay na, this much BOD is there. Okay na, and the spent water spent wash is treated using this much UA, that is upflow sludge bioreactor. Okay na, and the BOD removal is 85% when it is upflow anaerobic. When it is passed through this reactor, then 85% of BOD is being removed. A theoretical method produced this thing we already know. This time in the question they have already said it. Okay na, per kg of BOD removed, and the biogas contains 70% methane. So we have to determine daily BOD load, means how much BOD has been removed. Sorry, daily BOD means how much BOD is coming. That will be simply multiplying these two. Okay, then BOD load kg per day. Okay, now again we have to remove. We know that there is 85% removal efficiency. Then we have to multiply this thing and this thing. Okay now, total biogas production. Okay, so meter cube per day. So whatever BOD has been removed, we will multiplying it by 0.35. Then we will be getting how much biogas has been produced. And then methane production, we know that per biogas 75% methane is being produced. Then we have to multiply it by 70, and the equivalent they have said that per methane per meter cube this much equivalent energy is there. So then again whatever will be the answer of fourth, we will multiplying it by 9000, and we will be getting the energy equivalent. Okay now. Okay, so this was the first question, BOD load. The BOD load is can be simple flow rate into BOD concentration. Okay, now so again here I have taken care of unit. It is 50 kiloliter. Okay, now 50 kiloliter per day, and this much milligram per liter. Okay, now the flow rate has been converted into 50. Flow rate has been has been written in 50 liter per day. Okay, and this BOD concentration was given in milligram. Okay na, so milligram has been converted into kg by multiplying it by 10 to the power minus 6 or dividing it by 10 to the power 6. Okay na, so this much kg of BOD is coming, that is 6000 kg per day. Okay, then BOD remove, how much BOD is removed, it is saying that 70 for 780 removal efficiency is 0.85%. Okay, so this much BOD is coming into the system, 6000 is coming, 85% has been is the removal. So how much is being removed? 6000 into 0.85, that is 5100 kg per day. Okay, so this much BUD has been removed. How much production is there? Production is, see again here, there is a, if uh, again there is one here error, or again there is error, that is, it will be 0.35. Okay, no, not zero point 0.5. Remember, because it is 0.35. Okay, now the 5100 into 0.35 it will be. Everyone, are you getting it? What I have? There is a mistake here, that instead of biogas yield is, how much biogas yield? It is 0.35 meter cube. Okay, now, so this much of biogas is being produced, and whatever the biogas has been produced, only 75% is methane content. So that's why 255 into zero point 0.7 has been multiplied. So this much of methane is being produced. Okay, so energy equivalent, again they, whatever will be the answer of fourth, we have to multiply it by 9000, and then we will be getting what is the kilocalorie per day. So this much kilocalorie, or 16.07 million kilocalorie per day of energy is being produced. Okay, any doubt here? Only a small error was here, that it will be point, instead of zero point 0.5 it will be 0.35. Anyone, any doubt? If no doubt is there, then try to solve this question. That is, again related to same question. I want everyone. I want everyone to find out the answer of 1, 2, 3. Very simple question is there. Just you have to take care of the unit. This much meter cube of water per day with influent concentration of 900 milligram, removal efficiency 92%, theoretical oxygen demand is 1.42 gram O2 per CO2 per gram of COD removed. So here you have to, like, they are asking answer in kg per day. Everyone, please solve this question. Have anyone find out the answer of first one? You can write in the chat box. It is very simple. 540. 540 kg per day. Okay, good. It will be 600 meter cube is there. Okay, 600 meter cube is there. So it will be 900 into 10 ki power minus 6, and I will be converting into 10 ki power minus 3 liter. Okay, na, liter per day, and 900 it is kg, kg per liter. This liter gone. uh, uh, it will be 10 ki power 3, sorry, yeah. So 1, 2, 3, 5, this much gone. Okay, na, so yes, it will be 540. Oh, 540 will be there. तीन को तीन दो पाँच एक छः, हाँ. So it will be 540. Yeah, first one is correct. First one is correct. 540 kg. Here you can see that 6 kg they have. It is meter cube per day. 900 milligram liter. Then again here it's not shown, but it will multiply it by 10 to the power 3. Then if you finally convert it, then you will be getting 540 kg per day. What is the answer of second question? How much is being removed? Efficiency is 0.92%. So thus just we will multiply it by 0.92 and it will be 4. Good. Those who are solving it, very good. You have got right answer also. 460. And the final question was how much COT will be required. So here you can see that they have multiplied it by 1.42. O2 required. So this much kg of oxygen demand will be there. 496.8 into 1.42. Okay, na. So this much kg per day. Did you get? Everyone got this answer? Yes, good. Coming back to our previous question, did I made any mistake there? What? Let me check. 1.42 per gram. This one is correct. This one is also correct. Okay. One more question related to that thing only. But here we have used two things: anaerobic in your hybrid anaerobic reactor or anaerobic hybrid reactor, anything. So reactors are used, that is UASB and HAR. So this much of wastewater, that is 50 meter cube per day of wastewater having concentration of 40,000 milligram per liter. Okay, na. The USB has a BOD removal efficiency of 75%, while HAR has a removal efficiency of 82%. The effluent BOD from USB is further treated. So remember, first it is being treated from USB, UASAB. So consider this thing. This is our, suppose this is our this wastewater is being treated. So what will happen, that initially it will pass through USAB. Okay. So after treatment it will be passed through HAR. Okay. So and finally we have treated wastewater. Now suppose imagine that initially there is a concentration of 100 milligram per liter. As it is a removal efficiency of 75%, so the water coming out from here will have a only concentration of 20 milligram per liter. Okay, now 20 out of 20 milligram per liter, again here the efficiency is 82%. Okay, so what will happen, that here the concentration which will be coming out will be 25 into 1 minus 0.82. That will be equivalent, that will be nearly how much it will be, how much, 25 into 1 minus into 1 minus 0.82. So the concentration finally will be 4.5. Are you getting it? Similarly here, as the concentration is how much, 40,000, so we multiplied it by 400. Okay, so the final concentration will be this much low. Okay, so effluent from BOD is further treated to the biogas yield in USB reactor is this much meter cube per of BOD removed, while in HAR it is 0.5 meter cube kg of BOD removed. Okay now. So what is happening that in normal reactor anaerobic, as here in anaerobic reactor, the this much they have, see, generally it is 0.35, but as here it is saying 0.45, then we have to use this data only. Okay now. But in normal, how much biogas is yielded, that is 0.35. Okay now, 0.35 only. Okay na. But here as it is saying that we have to consider 0.45 for USB and 0.5 for BOD, then we have to solve as per that question. Okay na. So the total BOD load entering the treatment plant, have anyone found this? It will be again simple, very simple. As you have to find it kg, then it will be how much it is 50 meter cube, or 15 to 10 to the power 3 liter per day into 40, 1 2 3 4 into 10 to the power minus 6. Okay, so this 3 and this will be gone, so it will be 40 into 50, that is uh, this much. How much it will be? 10 got 3 foot 3 50 one jagah 20, then this much kg, per day. Okay, so you can see 20,000. Here also it is written that they have just multiplied 50 into 4, 50 into 10 to the power, again 10 to the power 3, not minus 3, 10 to the power 3 into 40,000 into 10 to the power minus 6, we have 200 kg per day. Okay, so so second question was effluent BOD from USB reactor. Okay na, effluent BOD from USB reactor. So again the BOD, how 200 was going on, 1 minus removal efficiency much this much of this much is the BOD. What I tell my, like, initially the 40,000 was going on here, 40,000 is going on. So the BOD which will be coming here, it will be, sorry, 20,000, 2,000 is there, 2,000 is entering. Okay now, so 2,000 is entering, the final concentration will be 500 kg per day. Okay now, so this is BOD remaining. Okay now, so again you have to convert into again as they have asked in milligram per liter. Okay now, as we know that flow will be same, so we will be divided by it flow rate. Again it is you have to convert into milligram per liter. Okay now, so again it was 50 kg, so I will be multiplying it by 10 to the power 6, which is done here, and divided by 50 into 50 meter cube is there, so 50 into 10 to the power 3, so finally this much milligram per liter. Okay now, so 40,000 milligram per liter was BOD coming, but after this USB reactor only 10,000 BOD is coming out, has the concentration gone to 10,000 milligram per liter. Okay, so and BOD removed from uh, now remember that after this concentration is now going into HAR. Okay now, so what will happen that the HAR effluent BOD will be from US will be 500 into 0.82, so this much is being removed. Okay now, so the final concentration will be, which will be, so if you make a diagram, so initially 2,000 was coming, it was coming to USB, then from here 500 is going, 90 410 has is removed, so final concentration which will be coming will be 90 kg per day. Okay, so this is what is written here. Okay, now so again, if we want to find out the biogas from USB, then USB remove biogas in 0.42. So this much was removed in USB into multiplied by 0.42. So this much meter cube is being produced from UASB reactor, and we know that 410 is being removed in HAR, and its biogas yield is 0.45. So 410 into 0.5, we have 205. So total biogas is 650 into 200, that is 880 meter cube per day. Okay, any doubt in this thing? So this was just interesting question that we are using two reactor. Okay, now and this type of question you can expect in your final assessment and all these things. Any doubt? I have more questions. So before going into that question, so was there any problem in assessment number 5? Sorry, assessment number 6. I know you have already some problem in 3, 4, 5, which I have already mailed them. But for last week, assessment number 6, was there any problem? Yes or no? Anyone? No. Okay then. So we'll be solving. I have several single choice. I hope you have all understood these numerical question. There are a lot of numerical question here in your. All are related to this thing only. Okay, na. You can see this thing we have solved. These are some of the examples. Okay, na. Here you can see this much is acidity. Average COD is there. Then they have asked everywhere. You will see that they have multiply it. Okay, na. Whether it is in terms of acidity, then if it is in acidity, then you have to like remember the unit. Focus on unit. Okay, na unit. Whether they are saying acidity or COD, just focus on your what do I call unit. Same question is there. Okay, na. You can see they have multiplied it. They will give you some thing and all this thing. Again here there is one numerical question. Same type of question. I have one. Throughout the PDF, similar type of question is there that something is being passed, this much is being removed. So how much methane? See this question we have seen. Okay, now so here you can see how much is being removed and all this thing. Okay, I hope these things are clear to you. So I have several question. Try to not see the answer. Which is the primary source of wastewater in? Just try to. These are very simple question, and I have lots of question. So answer it quickly. A. Yeah. This is the correct answer. Spent distillery generate wastewater from multiple sources, but the spent water is the most significant. Most significant, and it is that left. It is the residue left after alcohol is distilled from fermented molasses or grains. It has a high organic load, dark brown color, and a strong odor, making it highly polluting. Okay, so the correct answer was A. Which of the following method is most commonly used for distillery wastewater in India? C. What about other anyone? Everyone, I request everyone to please participate. C. Yes, C is the correct answer. That is, we can see that we have what we have uh, anaerobic digester or reactor we have. Okay, na for process, because this is very like this helps in biogas production also. Okay, biogas, yeah, biofuel in the form of methane, and this helps in burning and all this thing. Okay, na, so it's kind of sustainable method also. And there are several method. Anaerobic digester is there, then USAB is there, then we have HAR, that is hybrid anaerobic reactor is there. Okay, what is the typical pH range of spent was? C. C, I don't think. Oh, you might have answered as B, 3.7 to 4.5. B. Yes. Spent was is highly acidic due to organic load produced during the fermentation. Its low pH making unsuitable for direct discharge into water bodies and require neutralization before treatment. Okay, now. So this generally this okay. So this is the normal pH, and why this is and this pH is also necessary for fermentation also. Okay, now fermenters survive at this pH. So what happened that generally when we are treating with help of batch, we maintain this pH range. Okay, now but in case of biosteel, there is no such thing. In biosteel, we don't have to maintain any pH. It's already being maintained by internal mechanism. Okay, now. But once the treatment is fermentation is completed, the wastewater which is produced still will have those acidic condition or pH condition, and the final pH will be around 3.7 to 4.5. Which microorganism is only commonly used in ethanol fermentation? Coming in 1 minute. Yes, the correct answer is I am not able to pronounce it, but SS. I will call SS. Such a type of fish that is most commonly used microorganism for ethanol production because of its high fermentation efficiency, ethanol tolerance, and ability to thrive in acidic condition. How much water is generated per liter of alcohol in batch process? How much spent water? Spent was or wastewater in just beer in distillery industry means how much wastewater is generated for per liter of alcohol production? 10 to 12. One is saying. What about anyone else? B. Someone is saying 10 to 12. Oh, the correct answer is C. In batch process, around 14 to 50% of spent water is produced for every liter of ethanol. This is higher than the virtual process, which produces less waste per unit of alcohol. Okay, now in batch process. Okay, no problem. So the correct answer will be C. What is the primary method used for brewery wastewater treatment? That is in beer production or after beer, the waste which is being generated, which kind of treatment? Anaerobic digestion, chemical precipitation, electrocoagulation, activated sludge process. Answer is very simple. We use activated sludge process. Activated sludge widely used in brewery products. It is effective in reducing BOD and COD level through the microbial activity in the adjacent tank. And we know that brewery industry wastewater, in this kind of wastewater, we have huge amount of COD and BOD. Okay, now so here simple anaerobic digestion won't help. Okay, now we have to activated sludge, and I hope you recall what is activated sludge. Activated sludge is like this will be a primary treatment. There will be one more reactor. So what will happen that we will activate this reactor by passing some of the microbes from here to here. So it will contain wastewater, and we are introducing some kind of bacteria or microbes. Okay, so these microbes or bacteria will feed on the organic matter present in the wastewater. We are activating our whole system. Any doubt? What is the main organic pollutant found in the dairy industry? Easy, again, very easy question. Answer fast. I don't know why you are not answering. B. Yes, the correct answer is B. Dairy wastewater contain high amount of lactose, milk sugar, and proteins from the milk and its byproduct. Their organic compounds contribute to high BOD and COD level in the wastewater. Any doubt? You are not audible. If you are saying something, you are not audible. Hello. Please turn off your mic. Please turn off your mic. I don't know how to remove it.
আচ্ছা বেশ আন্টি সত্য কেস তো যাব লোন সব পেছাও একবার अरे लांड सोई का बाला रे ओके लाइक
Please turn off your mic. Hello. I don't.
minimum అమ్మారా చెల్లెను అమ్మారా కో ఎల్లెను
I don't want to do this thing.
ኧረ ምንም በቃ ንግዛ እኔ በጣም ይስማማል
Oh. Sorry for the inconvenience. Please keep your mic turned off. This is not good practice. Where is my cursor? My laptop is hanging little bit. I don't know why. Okay, coming back to the question number 18. I hope I am audible to you. So how much water is required to produce 1 liter of beer? See, yes, bring beer requires significantly water usage, and on average, 4 to 6 liter of water is produced. 1 liter of beer, including for raw material processing, fermentation, and cleaning. Which brewery waste has highest pollution load? Again, please turn off your mic. Blanket.
with
Please
fermentation
turn off your
and
mic.
with cool with fermentation
Please turn off your mic.
washing waster cool with
See, I have no other option. If you don't turn off your mic, I will remove you.
እዚህ ጋር ስለሚያስተምረው ስለ ሪሙቭ ነው ቢባል እዛ ሰውየው ሪሙቭ አድርጋለሁ አለ። ማየት እሱ ራሱ ይሄ ራሱ አስተማሪው ራሱ ማለት ቀጅበይ ነው። ጊዜ ይበጠብጣል እንትኑ ፓወርፖይንቱን ኦን ሰው እንዳይ
Much better. I don't want to do this thing, but he was not listening. That's why I have to remove it. Okay, you have joined. I request you to please turn off your mic. You were speaking continuously. That's why I removed you. I hope you have understood. If you want to say something, you are open to say. Miss, I have not stopped anyone, but my miss, I don't know what to say. Okay, so which of the has highest pollution load? C. Fermentation was. Yes, fermentation was is the correct answer. Fermentation was containing high levels of inorganic matter, alcohol, and sugar, leading to high BOD and COD level. This makes it most polluting waste stream in the brewery. What is the typical BOD by COD ratio in brewery industry? Anyone? I have got answer C 0.62. I'm searching one thing that there is one famous example. Uh, like there is generally answer will be C, that is 0.7 to 0.7. Can anyone say in which case the BOD by COD ratio will be equal to 1? I was searching for. I'm not. I don't. I also don't recall. I also don't know the answer. But this is very interesting question. That in which case BOD will be equal to COD. Generally, what happens that COD is always greater than BOD. Okay, na. It's like if you make synthetic water, that in that case also obviously there will be chances that BOD will be equal to COD. But there is one natural also kind of, I know, if a water containing only urea, in that case I think this BOD will be equal to COD. Just for your miss, I also don't know the answer, but for your own curiosity or curiosity, you can just check in which case BOD is great equal to COD. Okay, it will be never be higher, it will be always equal to. But just look into this example. Okay, now I was searching on net that thing only. But in this wastewater, the BOD by COD ratio is nearly 0.6 to 0.7. Which of the this is also very easy question. India is the largest milk producer, that is C. Okay, which is the most common biological treatment method for dairy effluent? For dairy, remember, for first, for alcohol wastewater we have used this aerobic reactor. Then for beer production we have waste water coming from the beer industry, we have used activated sludge. What will be the in this case which is the most common biological treatment method? Anyone? Just remember, it contain high amount of proteins and all this thing, high amount of organic matter. And so again, the answer will be activated sludge process only. Activated sludge process is the most commonly used method for treating wastewater due to its ability to handle high organic load and removal efficiency. Okay, what is the sorry. Oh, its answer is already here. Another question: what is the approximate pH range of dairy effluent? And the answer is 4 to 11. Dairy wastewater can have a wide pH range of 4 to 11 due to presence of acidic milk product, cleaning chemical, and fermentation bioproducts. Okay, na. So if a huge amount of acidic milk product is there, then pH will be in lower range. In absence of this thing, the pH will be in higher range. It depend upon the several factor. Which of the following dairy process generates the most wastewater? Answer this. D. Operation. D. Cleaning operation. Yes, generate the largest volume of wastewater in dairy industry. This wastewater contains milk residue, fats, and cleaning agents like caustic soda and acids. Okay, so they are different process. Okay, now so first is like different process, these are the milk reception, then cheese making, ice cream production, then cleaning operation. In this case, the highest amount of waste is being produced. We have already seen these questions, numerical question. Anyone have any doubt in this numerical question? Thank you. Try to answer this question. What is the recommended effluent discharge limit for BOD in treated dairy wastewater as per CPCB norms? If you recall, there are in India for drinking water we have. Can anyone say what is the Indian standard code for drinking water? And for pollution we have pollution. Suppose we have any wastewater and we are discharging it, then the norms is set by CPCB. Okay, na Center for Pollution Control Board. Like they have separated fourth thing that after treatment we can either discharge in river or in lake or in sea or in open field. Okay na. So depending upon the degree of treatment you can discharge on either of four. Okay na. So like there is certain limit. If your BOD is in X range, then you can discharge in river X1, it is X2, X3. Okay na. So depending upon this degree of treatment you can either discharge in either four of these. So that is controlled by. So my question was, for drinking water, which IS code we use? Anyone? IS code governing the drinking water parameter. This was this everyone should know this. 10500 2012. Mm-hmm. 2012. This has set a limit that this much limit should be on different water quality parameter: calcium, magnesium, TDS, pH, everything. Okay now. So question was around that if we are discharging from uh, uh, dairy industry, then yes, the correct answer is B, 30 milligram per liter. Okay, the maximum allowance of BOD concerning treated effluent is 30 milligram per liter before discharge into water body. Suppose if the discharge if discharge is in river or anything else, then there will be different limit. Okay, so it depend upon this thing. Why is anaerobic digestion preferred for distillery wastewater? We have seen that for uh, this distillery we use anaerobic. For other two we use anaerobic digestion, activated sludge digestion. Why is that? Can anyone say B? Yes, correct answer is B. It generates valuable bioproducts like gas. Anaerobic digestion reduces BOD and COD while producing biogas, methane plus CO2, which can be used for energy generation, making it economically and environmentally beneficial. This thing we have this is the repeat. This is the repeat of the what we have discussed. 5 to 7 liter. Which treatment method is commonly used? Try to answer it. In dairy, apart there was one thing which we see have seen activated sludge process. Apart from that, what is the other method that is also used? Just try to see that we have in dairy what we have several things. Proteins are there, high amount of COD, BOD. Depending upon this, which of these method can be used? A. What about other? Anyone else with any different answer, or everyone says A? The correct answer is A. The phosphorus removal in wastewater in dairy in dairy is typically done using chemical precipitation like agents like iron chloride, alum, or lime is added. So what happens that this reacts with phosphorus present in the form of P, and they precipitate generally Fe. Iron it's like what happened that iron. There are several processes, but either iron can react with phosphorus and they can precipitate. Okay, na. So similarly, aluminum and lime in the form of calcium, generally calcium phosphate solid are generally very stable. So what will happen that calcium is plus 2 PO4 depending upon the pH, it will be in different form. Okay, now it will be either in PO4 2 minus or HPO4 2 minus or H2PO4 minus. So it will react and it will form Ca, maybe CaHPO4 or Ca Ca5 PO4 whole thrice OH. These are some of things. This is generally very slow, but these are very commonly formed. Okay, now this is known as hydroxyapatite. This is known as monocalcium phosphate. Again, I don't know why the answer is coming. Huh. Just see the question. In which anaerobic reactor type is most commonly used for treating distillery spent wastewater in India? The correct answer is C, upflow, which we have already seen that upflow, generally combination of upflow USAB plus HAR. Okay, na. So what will happen that water will be passed through, it has a removal efficiency of around 80 to 90%. Again, it has a removal efficiency of 80 to 90%. So and a huge amount of the COD which will be coming in the range of 1000 kg per day and this thing. Okay, now. So we have seen a numerical question related to this thing also. I hope everyone is the answer is already the USB reactor is badly used for because its high removable efficiency in reducing BOD, COD, shorten retention time, and ability to generate biogas. Again, as it is contain anaerobic reactor, so it will produce methane plus CO2. This methane will be used to produce biogas. Okay, which is the main organic pollutant in dairy wastewater? Again, this thing we have already. B, the lactose and proteins. Typical COD. I think why it is repetition of previous question. Hmm. Which pollutant in dairy primarily comes from clean in place system? Phosphorus. Generally, in dairy we have this phosphorus problem. Okay, na. So you can just say cleaning agents like phosphoric acid and nitric acid used in CIP system contribute significantly to the phosphorus loading in the wastewater. Again, we have already seen this thing. What is the typical pH range of raw dairy? Huh? Oh, this thing we have also. See, this is the raw dairy influent. Okay, na. There was another question that was of wastewater related, that was between 4 to 11. Okay, now this one is different. The pH of dairy wastewater were depending on the variation involved, but is generally due to presence of milk. Nahi, that is a similar question, but I don't know, as per the option we have changed it. Okay, now but remember the general range is 4 to 11. This question is also wrong. Which city has the largest brewery producing this liter of beer per day? B, Bangalore. Yeah, Miss. I think you are able to answer. Miss, you have gone through the lectures. Good. Bangalore has the live producing. What is the main reason? What is the main reason dairy water is challenging to treat? B. B. Yes, high fat oil grease. Dairy wastewater contain fat oil grease from milk processing which can clog treatment system and need a specialized treatment like dissolve air flotation, that is DF. Yes, the correct answer is B. Oh, this was the last question. Uh, Anyone have any doubt? Just tell me one thing, from the next session you want theoretical question or numerical question? More emphasis on numerical question or more emphasis on theoretical question? Based on that, I will. If you see, if you have noticed, I have made too much theoretical question. So from next session, what should I do? Theoretical, please. Okay, both. Okay, I will try to balance it. Okay, now I was also realizing that this time I have added 43 question out of 35 question were repeated question. So only 4 question is of only 5 question was of numerical question. Okay, then the problem with numerical question is that I asked you to solve it, but only I was seeing that only one people was solving it. That's good. But from next onward, if I am giving numerical question, try to everyone should try to solve it. Take your time. We have 2 hours, so if we can utilize that in a good way. So from next onwards, I will try to give numerical question. Okay. And regarding the correction thing, I have already mailed them. Let's see what happened, but most probably you will get your marks. Any other doubt? Any other doubt, or should we end the session?